Okay, so today's notes are on vertex form of a quadratic, and our content objective is to identify and graph quadratic functions in vertex form. Our language objective is to use the correct terminology to describe quadratic graphs and their transformations. So the first thing I wanted to show us is a quadratic function graph. So we've been working with the equations, solving the equations for the x-intercepts or zeros root solutions. So we learned a few different methods for solving for these x-intercepts. Now we're going to actually delve into working with the graphs and plotting x-intercepts, looking at what the whole shape is, that sort of thing. So let's start with an overview of what the graph looks like and some of its key features. First thing, it is a parabola, which is just a U shape. So our quadratic function is a parabola or a U shape. The parent function, or the simplest form of our function, is just y equals x squared. So I actually plotted or wrote down a table here of some of the first few points on our quadratic graph. So the vertex is 0, 0, it's in the middle. I'll talk about that more in a second. And then I plug in -1 squared is 1, -2 squared is 4, 1 squared is 1, 2 squared is 4. So I just built this table by plugging in my x values, getting the y values. Don't worry too much about that right yet. We'll talk about it more in a second. The other key thing that I just mentioned is our vertex. So we've talked about this word before. It came up with our absolute value graphs. The vertex is the maximum or minimum point of our graph. So in our parent function, it's a minimum. So the vertex is the minimum point at 0, 0. The axis of symmetry is the line that cuts your graph in half exactly, or splits it in half. It's called the axis of symmetry. In this case, it's x equals 0. So it's along the y-axis. So x equals 0 is our axis of symmetry. We also talked about axes of symmetry when we learned about absolute value graphs. So notice that there's a lot of features and a lot of components that repeat from what we learned in absolute value here with our quadratic graphs. So a lot of things that we did with absolute value are going to come up again now with our vertex form or our quadratic graphs. So we have an axis of symmetry, a vertex, we have our table. The other thing that I wrote in here that you might be seeing is the number of units it moves from the vertex. So I noticed that when I move 1 away from the vertex in the x direction, I also move or go 1 in the y. So I started by noting that because this is going to help us in a few minutes when we get to graphing these. So when I move 1 away from the x, I move 1 away in the y. When I move 2 away in the x, I move 4 away in the y. So when my x is 2 from the vertex, I move 4, or 2 in the x direction from the vertex, I move 4 in the y direction from the vertex. So 2 in the x direction is 4 in the y. I hope that makes some sense because 2 squared is 4, so moving 4 units makes sense. I'm going to put a pause on that and come back to it in a few minutes when we get to actually graphing that. I just wanted to point it out while we were looking at that table. So pause on that. I want to back up for a second and talk about other forms of our quadratic graphs. So we have worked with standard form, which is y equals ax squared plus bx plus c. That's the standard form of our quadratic. We've worked with factored form, which is y equals a parentheses x minus p, x minus q. So it's just the factored form of your standard. We've worked with both of those in the process of solving. We've also worked with vertex form, though we haven't explicitly called it vertex form per se, or we've worked with a version of vertex form when we were completing the square. But we haven't talked about how this actually relates to our graph, so we're going to talk about that today. So y equals a x minus h squared plus k. This might look familiar. We'll talk about that more in a minute. A is our stretch or compression, and if it's negative, it'll also have a reflection. So A tells us our stretch, compression, and reflection. Maybe you're remembering where you heard this before. H tells us our horizontal translation, so it tells us left and right. So again, remember, it's always the opposite sign when you take it out. When you take it out, so H is always negative when you plug it, or it switches signs when you plug it in and take it out. K is your vertical translation, so how many you move up and down. So your vertex, so this is the key point that I want you to take away from all this, because I know not all of you love working with transformations. The point HK tells us our vertex. That's why it is called vertex form. So if you don't remember any of these other pieces right now, the number one key point I need you to remember, vertex form is called vertex form because H and K tell us our vertex. So that's the overview of what we're doing today. I'm going to flip the page and talk about a couple more things real quick. So the next thing I want us to do is recall. So you may, what I was mentioning before, you hopefully remember some of these things from absolute value functions. So absolute value functions are in the form y equals a absolute value x minus h plus k. So that's very similar to what I just showed you in vertex form. The only thing instead of parentheses squared is absolute value. So other than that, this is going to be more or less the same. So a, h, and k are the same transformations. That's why we talked about that vocabulary so much in Unit 2, because these are going to come up not only in our quadratic functions today, or our absolute value functions, now our quadratic, it'll come up in other functions later on. So that's why A, H, and K represent the same transformations. That's why we learn that vocabulary. Also, in the same way as absolute value, H and K is the vertex. So H and K is the vertex. A is still the stretch or compression, but A is not the slope anymore. Though it is, it is the stretch compression. So it is still the stretch or compression, but it is not the slope. So because it's no longer, the sides are no longer linear, it's not straight lines on either side, we have a parabola, a curve, it's not going to be as simple as our slope was for absolute value. Now it's going to be a little bit different because we're working with a curve. So that's the only big difference that we're going to have when we're graphing these, is we can't just follow the slope like we did for A before, though we can still plot the vertex in the same way, identify our transformations in the same way. So if you remember anything from absolute value functions, that will be helpful. If you don't, here's a chance to learn it again now. Also, one thing I mentioned, if A is negative, it will be reflected. So this is also true for absolute value graphs. The only thing that's different is that A is not the slope. It is just the stretch or compression because it's a U shape, not a V shape. So now we're working with a U, not a V shape, so we're going to have a stretch or compression, but not a plain simple slope. So let's actually delve into our example for today, or one of our examples for today. I want us to graph f of x equals x squared minus 5. So we're going to hopefully go through this relatively quickly. So step 1, we're going to determine the vertex. So I'm looking at h, there's no h there, so h equals 0. K equals, the number on the end is -5. So just so you know my thinking, h is always the number in the parentheses before it's squared. So if there's no number in parentheses before it's squared, then there's no h. H would be 0. So my vertex is 0, -5. So I'm going to sketch a graph real quick. My x-axis, my y-axis, I go 1, 2, 3, 4, 5. So I'm -5, 0. I can plot my vertex. So I determine my vertex and I plot it. Step 2, I'm going to determine my stretch or compression. So if you guys have already jumped ahead of me, my stretch or compression is my A value that's multiplied in front. Since the A value in front is just 1, there's not any this time. So then I'm going to jump right to my next step, which is going to be to make a table. So I'm going to make my table right here in my notes for the time being. So I have my X and my Y. I'm going to put the vertex in the middle. So I'm going to put 0, -5 right here in the middle. And then I'm going to go before 0 is -1, then -2, then 1 and 2. So I'm going to fill in my X values just by figuring out the numbers before and after it. And then I can use what I was talking about on the last page. So I know it's only going to go 1 unit when I go 1 unit from the x, and then it's going to go 4 units when I go 2 units in the x. So what I'm going to do here, 1 unit from -5 would be -4. So I know each direction here will be -4. If I'm going 4 units, so I'll just write this. If I'm going 4 units, because 2 squared is 4, it's going to be -1. Because 4 units from -5 is -1, it's moving up because it's not reflected. So I'm just moving 4 units up. So I'm going to go plot these points now. So step 4, it's going to be to plot points and graph. So I can plot my points. I have -1, -4, and then 2, -1, so 2, -1. And then I do the same thing on the other side. And then I connect my dots. Sorry, bear with me. This is not my best parabola. So then I have my parabola all plotted out. So I'm going to do one more quick check. If you don't have time and you need to go, you can stop your notes there. But I'm going to do one trickier one. If you'd like to stay around and see a more complicated example, I'm going to go through that now. So more complicated example. I want us to graph f of x equals -2 x minus 1 squared plus 3. So this is a lot more complicated than our last one, you might be noticing, but my steps are going to stay the same. So step 1, I'm going to determine my vertex. So my h here, remember it always switches signs when it comes out, so h is 1, k is 3, so my vertex will be 1, 3. Now I'm going to plot my vertex. So if I plot that, I'm going to give myself a little bit of space here. And I know I'm going to go up to 3. So I'm going to do a line here. 1. So I go 1, 2, 3. Plot my point. Oh, sorry, I got ink everywhere. But I plot my point. 1, 3. Now I'm going to determine my stretch compression. Stretch or compression. And in this case, A is equal to -2. So there's also a reflection, which means it's now going to open down because there's a negative in front, if you recall that. So sorry, I'm getting ink everywhere. So now I'm going to move on to my next step, make a table. And this time I'm going to show you, I'm going to put a little interim step. So I'm going to put my X on one side, then leave some space to do some work. And then I'll put my Y value. So I'm still going to put my vertex in the middle. So vertex still goes in the middle. And I'll do 2 before, 2 after. What comes before 1, 0, what comes before 0, -1, what comes after 1, 2, what comes after 2, 3. So I fill in my table. Normally, like we were saying, I'm going to go 2 or 1 unit away. So since this is my vertex, my middle point, I know this is usually 1 unit away. So, but this time I have to account for my stretch or compression. So I'm going to take my 1 unit, multiply it by -2, and I get -2. So now I know I'm going -2 units from 3 instead of going 1 unit. So what you do is take the number of normal units you'd go away from it, so 1, multiply it by your stretch or compression. I'm going to multiply it by -2, and then I'm going to add that to what I had before. So 3 minus 2 is 1. And this would be the same thing. It's going to be 1. This time, normally this is going to be 4 units away. So I'll do it down here so I have a little more space. So normally this is going to be 4 units. But this time I have to multiply by -2, and I get -8. So I have to go -8 units away from 3 this time, which is going to bring me to -5. And I know it's going to be symmetrical on either side, so the other side will also be -5. So now I can go ahead and graph So I'm going to draw my other points. I have 0, 1, and 2, 1. And then I have -1 and 3. That's a little too far. 1, 2, 3, 4, 5. So this one will be down here, and this one will be down here. And then I can connect all the dots. Hopefully your parabola looks a little bit prettier than mine. That's a little better. So that will be my parabola, and I have successfully graphed this quadratic. Make sure you write down any questions, comments, or concerns you have so we can go over them together in class.